How's it going, guys? Ron here from Speed Lab. Today we're gonna do a tutorial on O-ringing. This is from our buddy Kid. He sent this cylinder head from, I'm not sure what state, but out of state. Usually when we do O-ringing, what we like to do is we like to make sure the surface is, essentially the head's resurfaced and we have a nice clean surface to start with. However, on this one, it had a couple hundred miles on it. I'm not sure what the issue was. I think they were just trying to go for a little bit more boost and they didn't want to have any head lift issues, which we'll get into throughout the video. And I did check the cylinder head surface with a straight edge and it seems to be completely flat, so we don't have to worry about that. But this one's an exception most of the time. If you guys get a cylinder head from us, we resurface it completely. That being said, what we're going to do is we're going to put our O-ring fixture on here. Before we do any cutting, we're actually going to change the cutter bit. These are about 50-60 bucks a pop and they have 3 sides. And you get about 2 cylinder heads, sometimes 3 cylinder heads if you're lucky, per side. So, you know, not bad. Gets the job done. You know, definitely pays for itself, but they are expensive and I do like to have them on the shelf, basically just ready to go. And what we're going to do is we're going to bolt up this plate. We're going to torque it to 10 foot-pounds just to make sure we have even pressure across the cylinder head. Now, the reason why we do O-ringing is what it does is it allows us to use a MLS gasket. So for the Evo 8s and 9s, we use a Evo 9 multi-layer steel 5-layer gasket, which does great at sealing. However, at higher boost pressures, the head has a tendency to micro lift and twist. And when it does that, you know, what will usually happen is the combustion pressure will come out and it'll try to go through to one of the coolant ports from the actual chamber. And the head is not, you know, physically lifting an inch. It's micro thousandths, but it's enough to destroy the seal between the head and the cylinder block itself. So when we have an O-ring, that high pressure area that we create by putting that stainless steel ring in there essentially bites down on the gasket a lot more around the combustion area. And what that high pressure area does is it allows us to be able to create more cylinder pressure and hold more cylinder pressure without having the cylinder head lift. Now, if you are just crazy on the tune-up, you can still torch your head. It doesn't matter if you have O-rings. The only thing that'll kind of prevent that from happening is the fire rings that get machined on top of the block and get inserted. But that's a lot of cost and a lot of labor involved, and it's not very typical of a 4G63. With that being said, we have engines that are making close to 1100 horsepower, street-driven cars, race cars, and none of them have issues. Now, I will show you guys in a second, but we have over time developed this cylinder head O-ring program since 2020 or 2019. And we have gotten more aggressive with the projection of the ring itself. And the reason for that is whenever we do a service on the engine and we pull the cylinder head off, what we like to do is we like to take the head gasket, even if it doesn't have any issues. On an MLS head gasket, if you take it apart, the center layer will show you if there's any deformities or any micro lifting happening. So yes, even with O-rings, if you don't have enough projection, you can still put a lot of heat through the head gasket and essentially lift it to the point that it starts to wrinkle the gasket. Now, those engines that we pulled apart, they never had any cylinder head sealing issues. So they never pushed coolant, they never, you know, actually torched the head or anything. But just seeing that center layer tells us that we have more work to do. And this was about a year ago that we completely dialed it in. And now we don't see that wrinkling between the center layer. And it also, again, comes down to the tune-up of the car. So if it's an E85 car and you're running it at like 11.8, 12 air fuel at like 50 pounds of boost, believe it or not, some people do that. You know, you can still hurt stuff even though you have O-ring. So you can have the best of the best of the best and you can still hurt stuff if you're not careful with the tune-up, if you're careless, and or if you just don't have the experience and you're just kind of winging it. Anyway, so with that being said, this is going to be our latest and greatest per se. We project the rings about 9 to 11 thou. That's kind of the sweet spot. Anything more than that, you risk the head gasket itself not sealing because the ring height essentially is so much that, you know, when you torque it down, it might not, you know, completely sit on the head gasket itself. I hope that made sense. With that being said, I'm gonna put this on, I'm gonna torque it down, and then I'm gonna zero out our dial indicator to the surface of the deck, and then we're going to swap our cutter, and then we're going to start cutting. I'm gonna show you guys all of it. what I want to do is I just want to make sure that this measurement is actually correct, and we are at 0, or right at 0. We can see this is like half a thou, 0, half a thou. We're going to go to the next cylinder. There we go. That's good. So what we're doing right now is we're just making sure we have a 0 point to the deck. So when I'm starting to cut the groove, I can properly measure how deep I'm going. So what we use is we use a 041, which is a 41 thousandths thick stainless steel wire. This is very stiff wire. Some people like to use copper wire. I think it completely defeats the purpose of having O-rings because copper is super soft. So as soon as you compress it and torque it down against an MLS, you're going to get a little bit of a seal, but it's not going to do what this will do. But the tricky thing with this is you have to make sure you have the correct projection. Like I said, if you have too much, the gasket won't seal. But I feel like a lot of people use the copper, and it gives you a little bit more room for air. It's easier to take out, it's easier to install new ones in, whereas in this one, serviceability is difficult. As a matter of fact, the only way we can get these rings out is welding something onto the actual ring and pulling it out, which puts a lot of heat to the head. So every time we want to do this, we got to take out the whole valve train, the valves, the springs, all that stuff. Otherwise, the heat will just warp everything. So something that a lot of people don't think about, but this is a better way of doing it. However, there are more risks, so you do have to be a lot more careful with everything when you're doing these versus the copper. So copper is kind of like a quicker way, an easier way of doing it, even though the same amount of labor is involved in cutting and stuff. It's just more serviceable, but I don't think it's as effective as this. But to each their own. This is just my opinion, but I have done a couple hundred of these at this point, so I think my opinion holds a little bit of value, So this is just touching the surface. That's about 1 or 2 thousandths. So now what I'm going to do is so I said we're using 041 wire. We want to project about 10 thou. So I need to cut this 31 thousandths deep. So what I'm going to do is I'm going to go in 5 thousandths increments, because sometimes if you go larger increments, what will happen is the metal that is coming off as it's cutting it will get caught inside the groove, and the cutter will grab onto it, and it'll just destroy the groove. Ask me how I know. So what I'm going to do is, as soon as I cut about 25 thou, I'm going to take this tool off and I'm going to check the depth. I don't want to do that too many times, because there's a possibility that when you go back to put the tool in there, then it might shift a little bit and it might make the groove wider. That's the last thing you want, because we're cutting a 039 groove with groove, and we have a 041 wire. So if we cut it 1 or 2 thou off, then the wire won't have a press. So you still get projection, but it won't have press. That's why sometimes you'll see Loctite or even super glue underneath the actual ring. It's because sometimes they get cut wrong, and then in order for the head to actually retain the rings, you have to like glue them somehow, so whenever you turn it around to put it on the engine, it doesn't fall out. So yeah, interesting stuff. So we're going to be somewhere in the vicinity of 20 thou groove depth. I'm just gonna lift it, I'm gonna measure it once, and then I'm going to make my final cut right at 20. And the way you measure that is, it's obviously going the other way, right? That's not going up, it's going down. So 80 is actually 20, because if you deduct it from 0, 0, 90, 80. So our goal is to get to right at 70 or 69. So 69 is going to give us that 10 thou projection. And also what you want to do is you want to check every single groove, every single side, and make sure you're not more than half a thousandths off, because if one side of the groove is 5-6 thousandths off, it's going to drastically change your projection, and most of the time the O-rings are going to be useless. So you want to make sure that you take your time, make sure there's no burrs or anything getting cut underneath the actual cutter. But we're good right there. Two more cuts. That was 5 thou. My next cut is going to be 6 thou, which will be 11 total. Now, between every cut, I like to use a little bit of lubricant, usually a silicone lubricant or something like Croil that we use for rusted bolts and stuff as well. Before I used to vacuum this out just to make sure nothing gets cut underneath it, but I've done it so much now I know exactly how much I can cut and how much I can essentially get away with without cleaning. So as soon as I move from this hole to the next one, I am actually going to vacuum that. But before I used to do it with every single cut. So any material that would come off, I would just, grab it, but really don't need to get that crazy with it. And now this last cut, I like to put my hand on the center over here and then just run it a little bit. Now I'm not feeling any resistance. All I hear is the actual cutter in the groove, but it's not cutting anything. So the reason I'm doing this is so I can make sure there's nothing in the groove, and I don't have any inconsistencies from one side to the other. Okay, right there. Right at 69. Right at 69. So 041 wire right at 69. We're getting that perfect 10th hour projection. But this is what we're going to do across the board. So the way the cutter works is if I turn the dial here counterclockwise, it gives me cut depth. If I turn it clockwise, it actually picks up the cutter. So knowing that I cut 31 thou here and I have a 31 thou groove depth, what I'm going to do is I'm going to move this clockwise 30 thousandths, so 3 full rotations on the dowel, and then the first cut I make in theory should be 1 thou. And after that, what I'll do is I'll do the same thing as I did on this one. So I'll cut 20 thou, I'll take it up, and I should have 10 more thou to go. Now, you want to consistently check this if you have this fixture, because if you just make a mistake and cut it wrong and cut it too much, well, then you have to get this head resurfaced. So you're just creating work for yourself. There's a famous saying, everyone that's ever assembled anything or machined anything, they always say, measure twice, cut once, or if you're not measuring, you're guessing. This is literally the same concept. You want to make sure you're measuring every step of the way, just to make sure that you're not cutting your work out to be a lot more extensive than it needs to be. So it's a very long way of saying just double check your work, you idiot. Cut about 1 thou. There you go. Feels like 1 thou. And yes, you will get a feel for it if you use this every day. So right there, again, we're right at that 20 thou depth. So our calculations, I sound like a mathematician. I'm doing my job right, is what that means. Now Derek was just asking, what's a thousandth, right? So what's 1 thou? 1 thou is 1,000th. And this is 039 wires. This is 39 thousandths thick, and this is not super thick, right? Now, when we're talking about bearing clearances and stuff, usually we're in the range of 2 to 2.5 thousandths of bearing clearance for the connecting rods. And a human hair, a healthy human hair, not every single one. A healthy human hair is about 3 thousandths of an inch. Just to give you guys perspective of how tight these clearances actually are. So, another 11 thousandths and we are done with this hole. So this one, 1 thousandths under what we need to be. So I'm going to put the cutter back and adjust the dowel just a little bit, and we should be right there. See, it's right at the 30 thou mark. We want it to be 31. Now, is this going to make a difference? Probably not, but we want to be consistent with our work. So $31 thou groove that. Perfect. I'm going to check every single one. We're right there. Same thing with this. On the money. This one didn't cut right, so we're 5 thou under on this cut, but it's very consistent, so I know it's correct. And then I'm also making sure my tool is correct. As we can see, we're still getting the same number here, and I know it's 0 to the deck, so we're 5 thou off here, so right at 31. Perfect. Okay, so what I want to do here is I want to make sure that each end of the wire is going to be square. So I file it vertically like this, and then I'll go over the edges, make sure we don't have a sharp edge that's going to stick out. As far as the install goes, what you want to do is you want to have the end be close to where a head stud will go. The reason you do that is because the most clamp happens where the stud is. So if this faces the stud, you have less of a chance of the combustion pressure trying to escape here and, you know, compromising the head gasket. This is a 041 wire. The groove depth and the groove width is 039. The wire itself is 041, meaning it's 41 thousandths wide and the groove is 39 thousandths wide. So we have a 2 thousandths press fit. And for that exact reason, I have to basically hammer this, press this into the actual O-ring groove. That's also why it's so difficult to service, because once it's in there, it doesn't want to come out. All right, beautiful. So I'm gonna press it all the way up to here, and then over here I'm gonna make my final cut. I'm gonna make the cut a little bit longer. I'm gonna file the rest. I'm gonna make sure it's square against the other edge, press it all the way in. Okay, so right there, we're almost there. So this last bit, I'm going to file square. I'm going to keep checking my work. I don't want to overcut it and have a huge gap, because that's also going to defeat the purpose of the O-ring. 1, 2, 3. That's perfect. Now I'm going to make sure the edges are all good and there's no sharp edges. And I'm going to press the last bit of it in. You always do the check from the deck, make sure there's nothing sticking up. There's a part of the wire sticking up here. Another little trick that I do is whenever I'm butting the two ends together, I make sure that it has a tiny bit, essentially it's a little bit longer And the reason I do that is because whenever you actually put the ends together and you hammer it in, it has a press on the edges too. Again, that's also what makes it so hard to take out, but you want to have a perfect seal all around. There's this thing called Fuji paper or Fiji paper. Marco Pesante Magnus sells it. I'm sure you can get it online from other sources too, but what you can do is you can put that paper between the block and the head and put the head gasket in there and torque it down, and it will actually show you the imprint that the O-ring has. That's also where we learned with that paper is where it's very expensive. It's like $500-600 per roll. But that's where we learned like 7 years ago that if you are using like M11 head studs, which is still what we use today, but you go to like 120 or 130 foot-pounds, you're actually losing seal because you're reaching the tensile strength, you know, so you're essentially getting to the yield point of a fastener, and you're diminishing the actual clamp force if you're going at a higher torque. So we'll stay at 100 foot-pounds and we don't have any issues. You can go to 105, but there's no necessity, you know. These manufacturers, ARP, whatever other fastener manufacturer you buy it from, it's probably going to be ARP. They're the biggest ones. The range that they give you is under the yield point of the fastener, and that's where it's going to have the most amount of bite, essentially the most amount of clamp. ARP is not going to tell you torque it to 100 foot-pounds if you're going to get better performance at 120. So you're not going to outsmart the engineers at ARP by swinging your torque wrench another 20 foot-pounds. If you're doing that because you can't keep a head on your block, you either need a different tuner or you need to change your engine program. That's what it comes down to. Sorry to sound harsh, but if you have to swing your torque wrench to 120 or 130 foot-pounds on an M11 stud, something else is going on. I don't know how many engines I've put together at this point. I don't know how many cylinder heads I've done at this point. Every single one of them, we've torqued 100 foot-pounds with 625s. That's with regular ARP lube, nothing crazy. My drag car doesn't even have inserts in it. You know, there's a lot of stuff that you can improve. Yes, I agree, but you don't have to go to a 12mm head stud for a street car that's making 40-50 pounds of boost. If you're lifting heads at 40-50 pounds of boost, even at a 10-to-1 compression ratio, you need to get a different tuner or you got to revisit your engine program. Again, this is not, trying to be insulting to anybody. This is just, we've learned from experience, and you really don't need to, you need to follow the manufacturer's recommendation. You know what I mean? It's like torquing a rod bolt. They'll give you a torque rating and they'll give you a stretch number. You would want to go to whatever torque essentially that it'll take to get that bolt to stretch properly. Now, within reason. So let's say they give you a torque range of 55 to 65 on, say, a Crillo Pro H-beam on a car bolt or whatever. Just throwing numbers out there. If one bolt stretches to 7th thou, which is the spec, let's say, at 65 foot-pounds, the other one you have to go to 80 foot-pounds to get it to stretch. There's something going on there. So you can't also, overlook that part. But point being is these manufacturers are spending millions and millions of dollars on R&D, and for your buddy to just swing the torque wrench another 20 foot-pounds and say, the cylinder head's going to seal better, that's just not the case. So this O-ring procedure has worked really good for us, and we get people sending us their cylinder heads from everywhere pretty much to do this service, or if they buy a cylinder head from us, all of our cylinder heads now come with O-rings, unless somebody specifies that they don't want O-rings for whatever reason. So I'm going to finish this. I'm going to show you guys the final product, and then we're going to tear into some head gaskets that we've taken off previously from cars, and show you guys where the O-ring bites and where we usually see the culprit. So the center section of the head gasket on the Evos, on this particular type of gasket, will show you if there's a culprit. Now, be very careful when you're doing this. One time I was doing this on an AMG head gasket, M178 engine, which was the dry sump motor for the GTS. And I pulled it, and the crimp was so hard and the gasket was so thin and sharp that I sliced my fingers down to the bone. So with the Evo stuff, it's not crimped on as hard, so you can just very easily kind of pick it apart. This is what you're looking for, that middle layer. On this side, it looks really good. This is the latest projection. So this is like what we've been running in the last year. And we can see that there's no wrinkling at all here. And this engine saw 52 pounds of boost. So this is how you know the projection's correct. You want to check both sides as well, but for the most part, yeah. See, there's no wrinkling there. All right, so that's about it. Just got rid of a little bit of the carbon buildup in case for whatever reason they decide to just lap the valves and, you know, put this back to service and it doesn't go to the machine shop. I don't expect it to go to the machine shop because the cylinder head didn't get resurfaced, and I think they're gonna just put it back to service, no problem. That being said, this is how we O-ring cylinder head. So if you're interested in one, or if you want to know more information about it, just drop a comment or just shoot us an email and we'll be more than happy to help you out.